Guys, so today we're talking about quadratic equations, and we're basically talking about how to build them. And so, first part of our lesson, we're going to do two examples. We're going to do reverse factoring. Write a quadratic equation whose roots are. So if I told you the roots are 3 and -7, could you build me back the original equation? Let me get a hell yeah. Hell yeah, we can. Check this out. We got to start from scratch, though. And here's what you do. You say, okay, so you saw this back in the day, right? Like, do you remember me showing you work that looked like this? Do you remember? Kinda? Now, this is the long way of going about doing the problem. Let me build you back exactly in reverse how this works. So if you started right there, then the thing before it would have been this. And that means the thing on top of that would have been this, right? And that means the thing on top of that would have been this. Same thing for the other side. You like going in reverse much better, Max? And then once you have these two items right here, once you have these two binomials, guess what you do with them? Starts with a big F. Opposite of factoring. You straight up FOIL them back, and so you're going to get x squared. Oh, yeah, I messed up. This over here should have been a plus. So that should have been a plus. My bad. And so when you FOIL them back, you should get x squared plus 4x, right, minus 21. And that's the quadratic equation that we're looking for. So that's the quadratic equation whose roots are these two. Sorry, it should be equals 0 because it's an equation, and equations always have equal signs. Equations always have equal signs. Alicia, you're amazing, girl. Alicia said, for those of you that couldn't hear, she said, you know what? You don't even have to do all that, right, Alicia? There's a shortcut, and I don't think anybody else is going to do the long way going in reverse anymore. The shortcut is you just take the opposite of the roots and you stick them in parentheses. So it's going to be x minus 2, x minus 10, and then you FOIL those back really fast to produce a quadratic equation. That's going to be x squared minus 12x plus 20 equals 0. And that's the quadratic equation whose roots are that. All right, in the spirit of building quadratic equations, we're going to talk about the sum and the product of the roots because we're going to need these two items to build like really complicated equations. And good Lord, my friends, good Lord, what on earth is this long thing right here? What the hell is that? This is the general equation for a quadratic, and all we do normally is fill in a, b, and c with numbers like 2x squared plus 3x plus 4 to produce different kinds of equations. All right, guys. So we're gonna do number 3. So I gave you an equation, right? Quadratic equation. Can you find the sum of the roots just by plugging into this formula? Let me get a hell yeah. Oh yeah, of course you can. It's real easy. I mean, like, on a scale of 1 to 10, this is like a 1. What do you plug in for B? 5. So that's going to be negative. And what's A? Dose. So the answer is negative 5 over 2. And that's going to be the sum. And what about el producto, the product? As they say in Spanish. The product of the equation is C divided by A. And so we're just going to plug into it. What number stands for C? 8. Of course 8 stands for C. What number stands for A? 2. Record again. So now question number 4 is just like question number 1 and 2 that we did earlier, except that instead of being given nice, easy roots, we're given ridiculously complicated roots. And what we're going to do is we're going to use the sum and product to try and build back the equation. You see the sum and products have a and b and c in them. So if we can use these along with the roots, we can build this back. Okay, let's do this. Find the sum. Find the sum. You add these two together, what do you get? You get 6. Find the product. Well, let's go find the product. Now, you could actually multiply those out by hand, but that would be ridiculous, right? What's another way to do it? In su calculadora. Let's enter it in. You get 4. Perfect. And here's what you do next after you enter these two in. You use the two formulas that you were given before. The fact that the sum equals negative b over a. How much were the sum of these roots? They were equal to 6. That's the same thing as 6 over 1. So a, therefore, happens to be equal to 1. You see how it matches? How much is b equal to? Now, b is going to have to be equal to negative 6 because that's the only way that you could get 6 from this interaction right here. You see that? Whoops. Whoops. So b is going to be equal to negative 6. And then let's use the product to find out how much c is. Anybody know how much c is? Product is c over a. The product is 4 over 1. And so c equals 4. Now this is definitely a short answer question on your test, or something that looks like it. The final equation that you want to present is the fact that write a quadratic equation whose roots are 3 plus radical 5, 3 minus radical 5. You're going to say that y equals 1x squared, right, minus 6x plus 4. That's it. Let's practice again with number 5. So first we found the sum and the product of the actual roots themselves. Then we took our answers, we took our answers and we subbed them back into the general equations to find the sum and the product. We figured out what a, b, and c were, and we plugged back into the formula, and we're done. That's it. That's the answer. Let's play again. You've become a YouTube sensation. Wayne asked, is a always 1? What do you think? Hell no. Wayne, a is not always 1, and we're about to see an instance where a is going to be a different number. But let's go about our normal process. Let's find the sum and the product. I found the sum, but notice I didn't represent it as 2.5. I represented it as a fraction because that's the most useful way for going back and plugging into this formula right here, right? This is a fraction, so these should be represented as fractions. Don't give decimals, you'll get all messed up. Let's put this on video. Guys, multiplying fractions, right? Top times top, bottom times bottom. Look, 2 times a half is obviously 1, but it might be useful to keep it represented in its fractional form, right? So now we're going to go do the rest of it. Let's do the final last part of this. Look, what is the sum? The sum is negative b over a. Well, we found out the sum was 5 over 2, right? So how much is a worth?
2.
How much is b worth?
5. Negative 5.
Very nice. Now let's do the product real quickly. The product is c over a. And here's what I mean by keeping it in fraction form, right? Take a look. Are you going to sub in 1 over here, or do you want to sub in 2 over 2? You want to sub in 2 over 2 because otherwise the bottoms won't match, and you can't really use it. So you sub in 2 over 2, and how much is c worth?
1.
C is worth 2, right? the total product is worth 1, but C turns out to be worth 2. Now let's write out the equation, and we're done. And that's our final answer. So let's do it. Guys, question number 7, just like all the rest, let's see what we can do. So that's it. That's what you should have gotten. Let's go over once again. You find the sum, you find the product, you plug them back into the formula. Be careful though with 0 because 0 divided by anything is 0. So from this first one, all we know is b equals 0. And then we plug into the second one. Product equals c over a. That's 25 over 1 because we figured out the product was 25. Figure those out and then plug back in. Either one of those two answers is acceptable. Guys, so here we go. So turns out imaginary roots always come as conjugates. So you actually only need to know one of the roots when they're imaginary, and then you automatically get the other one. So let me give you an example. I was born July 1st. So if this is one of the roots, what's the other root? 7 plus 1i. Very nice. Let's play one more time. Give me another number. And what? Sure, 24 plus 8i. What's the other root? 24 minus 8i. They're never different, like completely random. They're always conjugates of each other. So, yeah, it does. I have that dictionary. Anyways, guys, so last question of the day. So we're finally done, and there's going to be no homework tonight. So if you know that one of the roots is 3 plus 2i, what's the other root?
3 minus 2i.
Very nice. 3 minus 2i. So you automatically know that the other root is just the conjugate of it, and then what are you going to do? What's the equation with these roots? All you do is do the same process we've done throughout this entire period, and let's get it done. I just got to go through it. So let's go through the work that we just did. First, once again, you know what the roots were. You find their sum. The sum is 6. Then the next thing you do is you find their product. You multiply these two together, and you get that the product is 13. You plug back into these formulas. You figure out what B and A are and C, and then take the result, plug it back in, and then you're done.